So welcome back guys, let's start with the OSI model. So the starting point of the networking is understanding of the OSI model. So you must have already studied and must be familiar with the theoretical OSI model. The OSI model is nothing but it is a stack of the layers. Each layer is tied to a particular networking functionality. So as you can see in the diagram, the theoretical OSI model consists of 7 layers. The physical layer is at the bottommost layer, followed by a data link layer, network layer, transport layer, session layer, presentation layer, and application layer. So this is what your standard book says, that theoretical OSI model consists of these 7 layers. So as I said, that each layer in the OSI model is tied to a particular functionality, and that layer performs only that particular functionality. That is, the layer implements a particular networking functionality, each layer in the theoretical OSI model. So we will discuss in brief what are the properties of the OSI model, because a question can be asked on this OSI model. So OSI model is nothing but is a description of the networking subsystem or the network stack. Please remember that the OSI model is also called as the network stack. Why it is a stack? Because the layers are stacked together on the top of the other. That is why it is also called a network stack. So OSI model acts as a guideline. So remember that the OSI model is a reference or standard, or it's a guideline. It doesn't mandate anything that you should implement your network stack which strictly follows the OSI model. It is just an advisory or recommending model. If you are trying to implement your own network stack, then you should follow the OSI model as a standard or as a guideline, but it is nothing like that. It is a standard which says that you must implement your own network stack as per the design of the OSI model. So OSI model is just a guideline. Then layers. As you can see that in the OSI model consists of 7 layers. Now what actually layer is? Layer is logically complete functionality of a networking component, and it is referred to as a layer. So every layer is tied to exactly one particular functionality. It doesn't happen that there is some functionality F, and this functionality is done by the network layer, and the functionality F is also done by the transport layer. It is not like this. Every layer has one specific functionality to perform, and that functionality is performed only by that particular layer. So we will be studying the functions and operations of each of these layers in the OSI model as we progress into the course. At that point of time, it will be more clear to you that a fair isolation of functionality is maintained across layers in the OSI model. So each layer has a specific function to perform. The functions of the layers do not overlap. So as I already explained, that there is no functionality which spans across 2 layers. The data packets moves across the layer bidirectionally. So we will discuss that in the OSI model, or in this networking stack, the packets move from top to down across the stack, as the packet also moves from down to top towards the top in this stack, and this happens across all the layers. So the movement of the packet is bidirectional in the network stack. So we will discuss in detail that why the packet moves bidirectionally in the stack and when it moves, and what are the changes in the packet that happens when it moves from one layer to another in the OSI model. Then all layers are stacked together to build a complete networking subsystem. So remember, all these layers work together to build a complete networking subsystem. And one most common example of the OSI model implementation is the TCP/IP network stack, which runs inside your operating system. So you already know that you must be having some IP address. The IP address is of the format of A, B, C, D. If your IP address is of this type, it means the OSI model that is running inside your operating system is called a TCP/IP network stack. So TCP/IP network stack is nothing but it is a instance, or it is a network stack which has been implemented using OSI model as a guideline. There could be other network stack that is possible, but the most widely used network stack is the TCP/IP stack. In the next slide, we compare the theoretical OSI model with the practical OSI model. So the practical OSI model is the instance of the OSI model that is actually running inside your operating system. And as I said, that the most famous practical OSI model that is implemented and is being used across the world is the TCP/IP stack. So it is this model that is actually implemented and is running inside your operating system. And the diagram on the left hand side is the theoretical OSI model. That is, it's a guideline, or it's a theoretical, it's a textbook version of the OSI model. Whereas what is actually implemented and is running inside your machine is the practical OSI model. So the difference between these two is, as you can see, is with respect to presentation layer and session layer. So there is no separate folder or separate files which implements the functionality of presentation layer or session layer in the TCP/IP stack or the practical OSI model which is running inside your machine. The part of the functionality of presentation layer and session layer are implemented by the application layer and the transport layer. So as such, if you browse your kernel operating system or the Linux operating system TCP/IP stack code, you will not see a separate folder for these two layers. The functionality of these two layers are subsumed in the transport layer and the application layer. Right? So this is the difference between the theoretical and what is actually currently in use. Right? So this is what is the actual implementation of the OSI model that is running inside your operating system. Please note that the application layer, it means the application. It is the developer's responsibility to implement this application. It is a networking application, of course. Transport layer, network layer, and data link layer are the part of operating system. The implementation of these three layers is inside your Linux operating system. Whereas the physical layer is also a part of the operating system, but it runs close to the hardware at the driver level. So to summarize, the transport layer, network layer, data link layer are the part of your operating system. As a developer, you don't have to write any code which implements these three layers, but of course there are APIs exposed by the operating system which you will use in your application to harness the functionality of transport layer, network layer, and data link layer. You will use these layers, but you will not implement these layers because these layers are standards. They are pretty much complex and they are the part of operating system, and these layers are already being implemented, well designed, tested, and these forms the networking subcomponent of the operating system. So to iterate once again, the presentation layer and session layer are partially implemented in layers above it and below it. So in this module, we will be discussing in detail the application layer. Of course, we will be doing projects and assignments. Those are all falls under the category of application layer because it is the developer who are writing application. And of course, we will be studying the transport layer, network layer, and data link layer in detail, how these layers stack together and work in coordination with each other to achieve the end result. And of course, the physical layer, on the other hand, is something that is a piece of cake for more of electronics or electrical students. As a computer science students, you can skip this physical layer because it's all related to electrical signals, which we place on the wire finally. So when the packet is when the packet is placed on the wire, it is placed in the form of electrical signals. So physical layer is more. Physical layer deals more with respect to electronic or electrical students. So in this course, we will not cover anything related to physical layer. If you are curious, you can always go to the textbook and read something about the physical layer. There's hardly any questions popped up from this area, the physical layer. But of course, if you are preparing for government exams and all, then of course you have to read whatever is there in your syllabus with respect to physical layer. So types of questions that are asked from the OSI model is as follows, that you will be asked that given a protocol X, where X could be ARP, it could be ICMP, it could be ping, it could be HTTP, it could be etc. So note that all these protocols are common internet protocols, and you must be familiar with these protocols, that how these protocols works and what are the use cases of these protocols. So the type of questions that is framed from the OSI model is that you will be given a protocol X and you will be asked that on which layer of the OSI model does this protocol operates. So note that it's ARP. So unless you know the functionality of the protocol and the functionality of the OSI model, you won't be able to answer this question. So you have to understand the OSI model, of course, at a high level, and you have to understand the protocol in question in a little bit detail to answer such type of questions. Also, you should know that what happens at each layer when a packet is received. For example, when the packet travels down the TCP/IP stack, what happens to the packet? When the packet traverses upwards in the TCP/IP stack, again, what are the changes in the packet? What are the fields which are transformed in the packet and why they are changed? So these type of questions are framed from the TCP/IP stack or the OSI model. So of course, in this course, we will going to study each layer of the TCP/IP stack in detail. That is transport, network, data link layer. So guys, in brief, in this course, we will go through the functionality of the common networking protocols, how they work and why they work, and in which layer of the OSI model or the TCP/IP stack they work. Then we will also discuss the functionality and mechanisms of layers of OSI model. And the last thing is that in this course, you will be given a various coding and project assignments. You must complete these projects and coding assignments and upload all the codes and all the work that you do on GitHub. So I've already illustrated what is GitHub account, how to use the GitHub account in my introductory video. So all the coding and project assignments are to be done and uploaded on the GitHub account. So going forward, so no layer is aware of the layer above it or below it. So note that data link layer doesn't know that the layer on the top of it is the network layer. Network layer doesn't know that the layer on the top of it is the transport layer, or the layer on the below it is the data link layer. So each layer works independently, right? So we will understand more that how these layers stack together to accomplish the networking subsystem functionality. Right now, at a very high level, you should understand that what is the purpose of each of these layers in the TCP/IP stack. So when suppose you have a network and you have the application X that is running on the machine A, and on the machine B you have the application Y, and suppose the application X has to communicate with the application Y. So the data will travel from the node A to node B through intermediate node, like the intermediate node B, C and D, and this cloud represents an internet. So internet means any number of routers or nodes can be there. So when the data from the node X, so the data that is generated by the application X has to go to the application Y that is running on some machine B in the world. So of course the data has to travel from node A to node C, from C to D, then from D to internet, from internet to then again node B. So you can see that in between C and D are called intermediate nodes. So data link layer is associated with data transfer from a node C to its neighbor node D. That's why data link layer is also called. So the entire functionality of the data link layer is related to data transfer from a node to its adjacent node only. That is from node C to D. It's the functionality of the data link layer. Whereas A is the source node, that is on which the data was actually generated. Such a node is called as source node. Whereas the data has to be received on the application Y, and the Y is running on the node B. The node B is called destination node. So it is the responsibility of the network layer to take the data or the packet from the source node to the destination node. Network layer doesn't handle any such scenario to transfer the data from intermediate node C to intermediate node D, because this functionality is achieved using data link layer. So network layer is related to the data packet transfer from the source node to the destination node. Whereas the third layer is the transport layer. The transport layer takes the responsibility of the data transfer from the application X to the application Y. Since application are the process, therefore transport layer is related to process delivery functionality. The transport layer doesn't know whether the destination machine B is C machine or D machine or any other machine in the network. All it knows that there is application X and it wants to talk to application Y. Transport layer doesn't know on which machine in the world the application layer on which machine in the world the application Y is running. Transport layer doesn't know this information. All it knows that the application X wants to communicate with the application Y, where application Y is some application running on some node in the world. So these are the functionalities of transport layer, network layer, data link layer, and as you can see that each layer is associated with its unique responsibility and functionality. From node to its adjacent node, the functionality is data link layer. From source node to destination node, this functionality is performed by the network layer. And from the process to another process, this functionality is performed by the transport layer. And of course, the application X and application Y that we are talking about here are the comes under application layer. The data, when finally placed on a wire, it is placed in the form of electrical signals. That part of the functionality falls under physical layer. So again, physical layer is more of electrical and electronics students piece of cake. So we will not discuss physical layer in detail. What we're going to discuss is application layer, transport layer, network layer, and data layer. So this is what a brief overview of the OSI model that we have just discussed. We will now dig deeper into the OSI model, that how things fit together to perform the complete networking functionality.